Hi guys, so today we're going to be learning about probability. It's going to be the focus of this new unit. So what comes to your mind when you hear the word probability? Maybe you think of cards or dice, or maybe you actually know the definition for probability and what that is. In class, this is going to be the definition that we'll be using for probability. And you might have had something that came to your mind that was very similar to this, maybe just worded a little differently. But we're going to say that it's the likelihood that an event will occur, okay? So maybe if you thought of like, okay, well, it's just the chance that something happens, this is just another way to say that, okay? So it's just the chance that something happens. So when we talk about probability in this unit, we can express it three different ways: as a fraction, a decimal, or a percent. And you should know how to change between each of these three pretty easily. And if you don't remember how to do that, like to get from a decimal to a percent, you just take the decimal place, move it 2 spaces over to the right, and that's where the decimal is now. So 6d percent. And that's how I change this decimal to a percent. And a fraction of decimal, you just do that in your calculator. One thing that we will be using a lot in this unit is this notation that you see over here to the right, okay? So when I look at something like this is just a way to symbolize that the P here stands for probability. You can think of the parentheses standing for the word of. So if I'm reading this, the probability of some event. So A is just a placeholder, but we'll talk about whatever event you want to occur would go inside of the parentheses here. Whatever you want to happen. So the lowest probability that you are going to encounter is a 0% chance that something happens. Okay, this would be if something were to never happen. There's a 0% chance it's not going to happen at all. Well, the highest likelihood would be 100%. This thing is definitely going to happen without a shadow of a doubt, okay? So anything outside of this range is not going to be a probability, okay? But if it's within 0 to 100%, all of that is free game. That is a probability. If it's outside of it, it's not a probability. So if we look at the following fractions, decimals, and percents below, which of these would fall within this range? Which of these are probabilities? Well, 1 divided by 83, if you change that to a decimal and then to a percent, that would fall within this range. So that works as a probability. Where this negative value, well, a negative is less than 0, so that's not going to fall within this range. It would be less than 0%. Not going to work. This one's more than 100%, so that is not going to work either. But this one would, so that would be within this range. And then the very last one, 4 divided by 3. Well, if we think of 3 divided by 3, 3 divided by 3 is 100%. Okay? So 4 divided by 3 would be more than that, so that is not going to work as a probability. All right, so now let's get into some problems. So a lot of stuff in this unit, when we deal with probability, we're going to be working with word problems, okay? So when we're setting up a probability, we're always going to start off by doing that as a fraction. So you're always going to get a fraction first. And then depending on the problem, it might want you to keep it as a fraction or change it to a decimal or percent, just whatever the problem asks you to do, okay? So this is how you would set up your fraction. In the numerator, you have your desired event. Okay, what event you want to occur. And then in the denominator, this is where you have the total possible events that could occur. Okay? And then once you plug those into your fraction, you can convert it as you like between decimals and percents. All right, so let's look at this first problem. We're going to use the spinner below to answer the following questions. So what is the probability that the spin wheel will land on green? Okay, so let's write this in the notation I just talked about up here. So what is the probability of us landing on green? That's what we really want here. Okay, what is that probability? So the green would be my desired event. This is what I want to happen. And that's going to go in the numerator here. So out of all the sections that I have divided on the spin wheel, there's only one green section. Okay, so my desired event is only going to happen one time. There's only one green section. But then the total amount of sections it could land on if it were to spin, including the green one, the total would be 6. So there's a 1 out of 6 chance that I'm going to land on green if I spin this wheel around. Okay. All right, next problem says, what is the probability of the spin wheel not landing on blue? So this would be not blue, however you want to phrase that. Okay, just so we know this is what we want to occur. Okay. All right, let's think of the denominator first this time. So we know just from the last problem that there's still 6 total sections here. Okay, there's 6 total different places it could possibly land on. I just care about the sections that are not blue this time. So how many sections are not blue? And that would be 5. So there's 5 out of the 6 sections that are not blue, and that would be my probability. All right, the very next 2 problems we'll look at are now going to be focused on this 20-sided dice. And you may recognize this if you play Dungeons & Dragons or something like that, or it may be very foreign to you if you don't know what Dungeons & Dragons is. But the shape that this 20-sided dice is in is an icosahedron. And yeah, it's a little weird. There's other dice that are bigger than just this normal 6-sided dice. So let's use this to find some probability. Okay, so what would be the probability of rolling an even number on this particular dice? Okay, well, since there's 20 sides to this dice, okay, that is the total amount of events that it could occur. There's 20 possible sides that it could land on total, okay? But how many even sides are there? So it's just the numbers 1 through 20, so there should be 10 even numbers from 1 to 20, okay? Please make sure that you are simplifying any fractions that you get if you are leaving something in fraction form. I think it specifies this in the assignments in Canvas to simplify, but please make sure you simplify this to 1/2. All right, and then the very last problem here says, what is the probability of rolling a 13 or rolling a number divisible by 5? I'm just going to kind of shorthand this so we know what we're trying to focus on. All right, so there's a little bit more to this one here. Well, I still know that the total amount of sides is 20. Let's think about how many numbers are there that are divisible by 5 on this dice, and how many sides are there? Well, I know that the number 5 is divisible by 5, 10 and 15, and also 20. So all 4 of those numbers are divisible by 5, and those are all sides on this dice. So I want the probability of landing on one of those sides, or 13. So I'm going to include just that side that has the number 13 on it as well. Okay. So those are all the sides on the dice that I desire to land on. Okay. So how many are there total? So there's 5 different sides that I am desiring to land on. Okay. So I have a 5 out of 20 chance of landing on any one of those sides. Okay, 13 or one of those 4 numbers. Okay, and then if I simplify this, I get 1/4. All right, the very couple last ideas we'll be learning about probability have to do with this idea of taking a coin, and we would do this in class if we were in person. But ignore what's written here, and let's just focus on flipping a coin. Okay, we want to flip a coin, and we want to know the probability of that coin landing on heads. Okay, do you know what that would be? What's the probability of it landing on heads? So if you are thinking, okay, well, that's just like a 50% chance, 1 out of 2. You're totally right? Like there's just a 50% chance that it could land on heads. However, Think about if you were to actually flip this in real life. You had a physical coin that you flipped 20 times, okay? So let's say if you flip this coin 20 times total, how many times would it land on heads? Well, 10, right? That's half of 20. But if you really, really, really were to test this out in real life and you got an actual coin, you can test this out yourself and see what happens, but you might get something like this. You might only get 8 heads out of 20 if you were to flip it 20 total times. Well, what's happening here? Why aren't we getting the number 10? And really, you can test this out and see, like, you might get the number 10, but there's a chance you may not get that. You may get something else. You might get over 10 or less than 10. But why is this happening? Okay. Well, the reason is because these are actually two different probabilities, two different types of probabilities. So the very first one that automatically just came to your head, like, okay, 50% chance, right? That is a theoretical probability. Okay, this is the probability that we expect to occur according to probability theory. Okay, we expected 50%, right? And then the other kind, what you actually got from flipping the coin, that is experimental probability. So that's the probability that actually occurs from the results of an experiment or simulation. Okay, so there's two different kinds of probability going on here. Now, you might be thinking like, okay, why do we use theoretical probability then? Why do I think that there's a 50% chance when it might not actually happen like that in real life? Why do we even do this? Well, the reason is because of this next crazy thing that I'm going to show you. So let's say you yourself, you flip the coin, you got heads 8 out of those 20 times. And then you have a friend, and they also flip a coin 20 times, but they get it heads maybe like 16 times out of 20. And then you have another friend, and they get 11 heads out of 20. And you have a lot of friends, so you have them all just flip this coin 20 times. And you get all the results from all your friends. If you were to actually take maybe those 100 or 200 friends that you have, and if you averaged, so if you took the average of all of their results, it would be 50%. Okay? So the crazy idea here is that the more times that you do an experiment, okay, the more trials you add to your experiment, the closer and closer and closer it gets to theoretical probability. And eventually it turns into the theoretical probability. It turns into that 50%. Even though it wasn't there originally, if we do the experiment enough, it gets there. So this rule is called the law of large numbers. Okay? So it's a principle of probability that says as the trials of an experiment increases, okay, so if the frequency increases, the probability of the experimental probability, so your experimental probability, it's going to converge, or in other words, get closer. It's going to get closer towards the theoretical probability. So just in case you're not 100% comfortable with the word converge, the actual definition is when something approaches, gets closer to a definite point or value. And here, in this case, it approaches 50%. That's the definite point or value. Here are just some more visuals to help you kind of get a better idea of what we're talking about. Visuals always help me. So if you look like these first two, I don't even know what to call them, but they're just adding little dots together. But we can think of like the first column here as heads. So this is how many times you got heads if you were to flip a coin. And then the second column, you're tallying up the tails, okay? And so you imagine flipping a coin and you're like, all right, I got heads this time, tally, mark, and then tails this time, and then I got tails again, and then another tails, and then heads, and you keep on doing this and you count up how many there are. That's what this is doing right now. So I want you to check out this thing, this pie chart, okay? So we'll kind of just wait till it starts over from the beginning, because check out what happens when it starts right at the very beginning of when you're doing this. Okay, this thing is going nuts. It just like went all over the place. But then, as we start to add more and more trials, we do this more and more times, we have more and more friends that flip the coin, it starts to stabilize. And if we notice where it's stabilizing at 50%. And we can see this do this a couple more times. It does a couple different trials of this, but we can see at first it gets all crazy, kind of just like this graph here. When you're flipping your coins, it starts off being really crazy, the probability, but then the more times you do it, as your trials increase, it starts to stabilize, okay? Or in other words, converge. So we can see here it's converging towards 50%. So that's the value. Another word that has to do with converge is also diverge, which is where it's not approaching a definite value. This is where it goes off towards infinity. And you'll learn more about this word when you get to calculus. But for now, we know that when we use the law of large numbers, that value, it converges towards 50%, at least when we're doing heads and tails.